everybody. This is your calculus video on 3.1 derivatives, having to do with tangent lines and derivative at a particular point. So what we're doing is solving problems involving slopes and tangent lines, interpreting derivative values, rates of change, testing for tangent lines, and the vertical tangent lines. So why we're studying this is the derivative is used to study a wide range of problems in math, science, economics, and medicine. These problems include finding solutions to very general equations, calculating the velocity and acceleration of a moving object, describing the path followed by a light ray going from a point in air to a point in water, finding the number of items a manufacturing company should produce in order to maximize profits, studying the spread of infectious disease within a given population, and calculating the amount of blood the heart pumps per minute based on how well the lungs are functioning. Historically, geometry was discovered much earlier than calculus. The Greeks were the first to study geometry, particularly Euclid. Calculus was based on Isaac Newton and Gottfried von Leibniz. The two main questions are the steepness of the tangent line, which has to do with derivatives, and the area under a curve, which has to do with integrals. There is a formula you're going to have similar to what we've done before, where it's the change in y over the change in x, which is really just h. And that's called the difference quotient. A lot of this is going to look similar to what you did before. On some problems, once you find the slope from the limit formula, you need to use the point slope form. Sometimes you need to expand an expression to the third power. So you may want to expand the quadratic first, then distribute and combine like terms. And remember to get a common denominator or multiply by the conjugate whenever it's necessary. And remember the limit formula has divide by h, and to put it at the right place in the equation. So here's your summary of it. The following are all interpretations for the limit of the difference quotient. The slope of the graph at x equal x0 or x naught is what they call it. The slope of the tangent line to the curve, the rate of change, and the derivative. So anyway, there's general things. Now, specifically on your problem set, I'm waiting on this to blend in. Okay, good. So what we could do is do this like we did before. Type in 2 minus 2x squared, enter. And we're interested in the point 3, negative 16. So we're going to find our dy dx, which is number 5. The position is going to be 3. And it tells me the answer is, I think that's negative 12. Yeah. So similar to what we did before, that was put this as F1, then use menu, analyze graph, dy dx, and the position is going to be 3 since it's from 3, negative 16. And the answer was negative 12, which means the slope is negative 12. So then, again, if you want to do what we did before, we just had y equal mx plus b, acted like this is x, this is y, and we knew the m was negative 12. So you have negative 16 equal negative 36 plus b, add 36, and we get 20 equal b. So it's y equal negative 12x plus 20. So that's what we did before, which is completely fine. Remember, sometimes they put the y equal, sometimes you have to, so just be careful. The other way is with the y minus y1 equal m times x minus x1. Just to remind you of that, so we can say y minus, the ordered pair was negative 16, so we change this to plus 16. Then we have a negative 12 here and x minus 3. So at that step, we would want to distribute and then subtract 16. So y equal negative 12x plus 20. So there are two approaches to the same thing. Most of y'all probably want to use y equal mx plus b, which is the slope intercept. But if you'd rather use the point slope, you can, because we figured out the slope and we have a point. So anyway, they both work. Now on this one, they want the equation of the tangent line to the curve. So what we're going to do is figure out our slope. So we're going to type in square root, or 6 square root of x. Then we go menu, analyze, dy dx. The position is 9. We push enter, and it tells me the answer is 1. So m equal 1. From the analyze graph dy dx. And now we go y equal mx plus b, 18 equal 1 times 9 plus b, and then you subtract 9 and we get 9 equal b. So that would be y equal 1x or just x plus 9. So that's what you get. And then you want to pick the correct graph, and looks like a couple of these have the correct y-intercept, but the difference is this splits out a little bit more and this stays similar. So what you want to look at is your window. You want x min to be 0, x max to be 20, y min to be 0, and y max to be 40. So I just wrote those right there, and let's do that. And also I want to put in x plus 9. So now menu settings from 0 to 20 and from 0 to 40. So there's the little gap. Both of them kind of show the hole in the graph at 9. Just to me, that's the easiest way to see. Okay. So now for our next one, we've got negative 2x cubed, and so then we get our slope from dy dx. menu, analyze, dy dx. The position is -2, enter, so we get -24. This time I guess I'll use the other formula just for variety. Because whenever you take college algebra, if you have to take that, they're going to want you to learn both methods. Notice we are putting x plus 2 because it's minus a -2. I'm going to go ahead and add 16 over here. So that's your answer. By the way, in calculus, sometimes they have a variation of the point slope formula, and that is y equal mx minus x1 plus y1. So it's like just moving this one over, which is like okay, it's just solving for y. And then the curve is like decreasing basically, so it can't be that one. And if we put in our -24x minus 32, there it is. And again, change your settings. -40, actually -4 to 4. And then -40 to 40. So it's going to look like that. So again, x minimum, x maximum, y minimum, y maximum. So this does all look like a good graphing window, but just look how different your scale is. You know, you're counting by very small values here, but counting by whole numbers horizontally. So pay attention to your scale. So I guess the difference between these two is this hovers around the x-axis longer. And this one goes up and then like that. Looks like a lot of these are the same type problem. So on this one, we're doing x squared minus 6. Then we do menu, analyze, dy dx, position 3, and our answer is 6. So this is m equals 6 from dy dx. And again, we do y equal m x minus x1 plus y1. Y equal, the slope is 6, the x is 3, and then this is 3. 6x minus 18 plus 3 is 6x minus 15. Okay. On this one, the calculators really are useful for y'all. I mean, obviously. I guess before I do 5, just what I had to do, whatever year I did this, which I think was in 2019, we had to work this number 7 by hand, multiply by the conjugate, just to get the slope to be 1, and then had to work it out. And then later I figured out do menu 6-5, position 1, answer 1, and then that. It says also graph on 5 to 10. So those are pretty similar. Now on this one, again, we're going to just do the same thing. 2x squared plus 3x, menu 6, 5 in my case, position -3, I get 9. Oh, that's a -9. There's the negative sign right in front. So then y equal mx minus x1 plus y1. So that's going to be -9x plus 3 because it's minus and negative, and then plus 9. And this turns into -9x minus 18. This one, same thing. (5x) divided by parentheses x minus 2. Your graph is up there. We care about 315, so let's change this to like 30. Okay, then you can see it a little bit better. Menu, analyze, 5. The position is 3. And then I get an answer of -10. So then y equal mx minus x1 plus y1. And -10 times -3 was positive 30. And then combine your like terms. So that's that. On this one, doing our graph, remember to not use t in the calculator, use x. Answer 6. M equals 6. From dy dx. I also said use x, not t. Or your calculator. Then we do y equal mx minus x1 plus y1. So that'd be 6, x minus 1 plus 2, 6x minus 6 plus 2, 6x minus 4. But now remember, if they use that variable, then you have to change it back. So 6t minus 4. So change your variable back. Change the variable to the original t. Okay. Again, more of the same. Square root of 2x at position 18. So when I did that, it pushed my window over for me. Now I got this decimal, and so remember that last 7 was just a rounding issue. So keep it 6 right here, go halfway, and get it as 1/6. Okay, so the calculator showed 0.16, a bunch of 6s and then a 7, but convert 0.16 repeat to the fraction. Don't use 7. which was the rounded number. Okay, so now we have m equal 1/6, and so we have y equal m, x minus x1 plus y1. So y equal 1/6, x minus 18 plus 6. 1/6 x minus 3 plus 6. So that's 1/6 x plus 3. So what I did was 1/6 times negative 18 is negative 3. So then that's your answer. Looks like on most of these, they already have the y equal given for you. Just be careful. On this one, we now have the square root of 5x plus 11. Menu analyze dy dx, push 5. So this is 0.416 repeat. Just repeating the 6. Again, notice there's a 7 in the back. I'm wondering if we could do it this way. Yeah, it's highlighted, so you can do Control C for copy. Then you can go over here and do Control V for paste, and then change this one to a 6. And let's keep going a little bit. Menu, number, fraction, 5/12. So you were able to copy, paste, and we get m is 5/12. And that's your formula. So this would be 5/12 x minus 25/12 plus 6. Now, on the calculator screen, I'm going to say negative 25/12 plus 6. It gives me 47/12. And that's what we have. Now this one, a couple of these only want the slope, which is easy. (2x squared), menu, analyze, dy dx, position -5. It says -20. And that time you don't have to get your equation. Then on this one, 1 over parentheses x minus 5. And they have position 9. So that has this decimal. I'm going to copy this over. Control C. Then I'm going to press on. Then I'm going to go to calculate, then Control V. Now this one does not keep on going, so just get it as -1/16. I had to convert that to the fraction. And then on this one, and we care about it 0. And the position 0 gives us 0.5. Which is a half. Now these couple of them just say simplify your answer. Of course on your key it's showing as fractions. I don't know whether it would count that right or wrong if you put a decimal. I would just use a fraction, but it's up to you. Now we have a word problem. In a controlled lab experiment, the yeast cells are grown in an automated cell culture system that counts the number P of cells at hourly intervals. So these are your hours, and these are the number of cells. Explain what the derivative P prime of 6 means. It represents the rate of change at t equals 6. It's not the number of cells, it's the rate of change, because derivative was defined as rate of change. And then the units are number of cells per hour. Okay, which is basically that one. Remember, if it has a number, it's multiple choice. Then it wants to know which is larger. They don't actually make you get the value, which is probably a good thing because you don't have a formula. But if you're comparing t equal 2, it'd be like that, sort of, and t equal 4 would be like that, which is slanted up a little bit more. So the slope is greater at t equal 4 because it's slanted up, or slanted higher at 4 than 2. Okay, then now they're telling you the equation, and they want to know the instantaneous growth at 6. So go to your calculator. (9.94x² minus 31.99x plus 20.5. Menu, analyze, dy dx, position 6, gives us 87.29. So you do this the same way as before from dy dx. And it wants the unit, which would be cells per hour. Not squared, not just cells, not just hours. And then there's a couple of these. Now, when I did this one before with growth of yeast cells, we had to do it by hand, and we did the change in y over the minus the change in x over h, and we basically had to expand all this stuff, but you were able to get it, with your calculator. Now, with the next one, it's talking about horizontal tangent lines, and we had to graph it and then find the minimum or maximum. Since it's a positive in front of the x squared, it's the minimum, and that's the y value -5. So that's number 25, which is the same thing as this. So in the book, when I did it, it was a whole number basically. But on this, it looks like a fraction. 3x squared. Yeah, if you have a number in front of x squared, it's probably going to be a fraction. So in this case, you want to do menu, analyze, do minimum. Menu, analyze, minimum, which was number 2. and I want to trap it between here and here, and it changed my window for me. Changed the window automatically, and I see 1.49, and then I see some garbage at the end, and I see negative 8.75. I see a bunch of 9s, and so that's why we just make it negative 1.5, which is the same as negative 3/2. And this other part is negative 8.75. So we can type negative 8.75 menu number fraction, and that's where we get negative 35/4. And so then you just put those together as a fraction, as an ordered pair, and remember your parentheses. Remember the parentheses. Okay, so then let's do it on number 15. At t seconds after liftoff, the height of a rocket is 5t squared. How fast is it climbing 10 seconds after? So let's just try it with the same approach. 5x squared, menu, analyze, dy dx at 10 seconds. Tells me 100. So that worked. This was menu, analyze, dy dx, and it said 100, which is your answer. And then again, like on the book, we had an object drop from the tower, and we had to plug in 2 for our x value and do the math. Again, you're fortunate we know how to do this better. Now on this one, it's talking about a circle's changing area, which said if you use a slider or a different type of variable, we had to work it the same way. Yours is the area of a square, and then we care about 12. So you go x squared, menu, analyze, dy dx, put 12 in, and there's your answer, 24. Menu, analyze, dy dx, and you were given m equal 24. So this again, position 12, and your answer is 24. Okay, so we got all that done in one video because we know our technology. Yay, math team. Have a good day.